Okay, good morning to everyone. So welcome back to our experiment. So this time we will be doing a combination of piston bridge plus the amplifier. But before doing that, we will go back to our amplifier first. So we have to check now the output of our amplifier or the operation of our amplifier. Here I prepared a small setup with regards to our amplifier. So here you will see that there is you have here a 741 amplifier. Okay, so it's now basically it's connected now to our supply. Our supply is just positive 10 volts. No, we don't have a negative voltage. So we will bear with that first. So this one, as you can see here, this point, that's negative. I'm going to measure it later. So this one is connected to number 4, and this one connected, our positive is connected to number 7, as we all know. So this is the positive terminal for our 741. By 746, I'm going to collect now my output 746 so that I can measure it from here. So I put a line going here. So I'm going to measure. I put here the terminal or test point, what we call. In electronics, we usually call this one test points, where we connect, where we can easily connect our instruments. So these are our test points. So these are this is for negative voltage. So this is for positive voltage. So this is for output negative 6. So this one I'm going to show you the measurement. I'm also going to use now our potentiometer here to provide the voltage. Now basically I'm going to make a voltage follower. Okay, voltage follower. What's a voltage follower? So we have learned that a voltage follower, so our amplifier will simply follow the input voltage. So I'm going to set it up later. I'm going to put a line from negative to negative input or output going back to negative input. So this my potentiometer is connected here. From you will see that's connected my two lines of my potentiometers from here and here. So connected to the ground, and the other one to the positive 10 volts. Right? Then the pin 6 is connected here. So I'm just going to connect this one here later to our input of our amplifier. Okay. Okay. So this is my probe now. I'm going to measure now our input voltage, meaning the supply of to our amplifier. So I'm going to put it here, there. So it says there 10.3. So you have to put that 10.3 so that you're going to compare it to our saturation voltage. Maybe later, up to what voltage it will, our output will come up. Okay, so that is 10.3 our input voltage. Now I'm going to show you here the output of our potentiometer here. There, as you can see, it's 5 volts. Now, as we have learned, potentiometer provides variable voltage coming from a fixed voltage. So our voltage, as you have seen, is 10.3 from here to here, 10.3. So I will be collecting voltage from the middle. So as you will see there, it is increasing. Right? You will see that's increasing. So meaning I can provide now different voltage level just collecting it from the potentiometer. So our first setup will be voltage follower. That's the easiest way to check whether your amplifier is good, no? Okay, it's not defective. So I'm just going to connect now wire from the output here going to my negative input. Then I'm going to connect the output of my potentiometer to the pin 3, which is your non-inverting input. Okay, so Let's do that. Okay, so now, as you have probably have noticed, I have already connected here the output pin 6. I feed it back to pin 2 of our 741, so that is output 6 to my pin 2. So I just feed it back. If you will recall again, our voltage follower circuit, where our output 6 is just simply connected to our input 2, or your inverting input, your negative, your inverting input. No resistors there. Then I connected the output to my potentiometer from the middle, the slider of our potentiometer. I connect it to pin 3, the non-inverting input, so this positive. So since I cannot get a negative output from my amplifier, because I have a fixed voltage of 0 to 10 volts only, I don't have negative voltage, so that's the only way we can check our amplifier. Okay, so I connected here my output of my potentiometer to pin 3. Then as you can see, it is the meter is connected there, so 0.4 as you have earlier seen. So this is just following. Okay, so this is the output of your voltmeter. So let's check whether I will get the same voltage as the output from my amplifier. Okay, so here I'm going to remove it here. I'm going to connect there. So it's the same, basically the same. 5 volts, right? Our 5 volts here is from 5 volts. Let's check whether it will follow. As the name implies, it's a voltage follower, meaning the output of the amplifier will simply follow what is the input. So let's check here. I'm going to change now the output from my amplifier. Okay, see here. So it's changing, right? It's changing, right? It's increasing. Okay, I move it down. Okay, so that is decreasing. So you can include this in your experiment as an experiment for your voltage follower. So this is one way of checking whether your amplifier, your 741 amplifier, operation amplifier, is defective or not. That is the best way to do the experiment. First, validate your material. First, validate your devices if it is working properly. Right, so this one we have seen that the potentiometer is working properly. Then I have proven to you that the amplifier is doing the same. We can do another test. Okay, we can do another test by making it as a non-inverting amplifier. Okay, because in the non-inverting amplifier, we still can get positive voltage. We cannot do the inverting amplifier. Why? Because I do not have a negative voltage. I cannot collect a negative voltage. Okay, so what I will do now is to connect the circuit from this voltage follower. Voltage follower, as you can see here, is the voltage is following. Okay, I'm going to connect it now as a non-inverting amplifier. Okay, this setup now is set up to become a non-inverting amplifier. Okay, non-inverting amplifier. As we all know from our lesson, non-inverting amplifier, the feedback, the output 6 from pin 6 is feedback to pin 2, our non-inverting input. Okay, then on the same point, pin 2, our Rin is connected to the ground. Now, since they have the same value, my Rin and my RF is the same value, that is 1000K. okay, 1000K. So we can calculate for the gain, right? As we have learned, the gain for non-inverting amplifier is 1 plus RF over Rin. Now, since they have the same value, RF and Rm the same value, therefore our RF over Rin is equivalent to 1 plus 1. Therefore, our gain will be equal to 2. So, meaning, whatever we input to pin 3, our non-inverting input, it will be doubled. Okay, we're going to double it because our gain will be 2. Alright, so gain will be 2. So, I'm going to adjust now the volt, or we're going to measure what is the voltage here present in pin from our potentiometer. Then we will check the output from our pin 6 of our operational amplifier. Okay, we'll check. So as you can see there, this is the output pin, this is the output of our potentiometer, which is fed to our pin 3. Okay, so I'm going to measure it here. Okay, so it says there 3.3, or approximately somewhere around 3 volts. Okay, then we're going to check now what is the output at pin 6 here. Okay, good. Exactly. 3.3 multiplied by 2, that is 6.6 exactly. Alright, so we have done already 2 experiments. Voltage follower and non-inverting amplifier. Okay, so let me show you that. Let us check how much will be the saturation voltage. Remember earlier that our voltage input is 10.3 something. Then we will see how much it can provide. Okay, so we continuously increase the voltage. Okay, only up to 9.2. However, I increased the input voltage, so let's check now. Let's check what is the input voltage now here. So the input voltage is 7.3. 7.3 multiplied by 2, that will give us 14.6. But of course, we cannot get 14.6 from a supply of 10.6. Now, remember, our supply is different from our saturation voltage, the output from our pin 6. Theoretically, it's supposed to be like that. The maximum voltage that your amplifier can provide is the supply voltage of your amplifier. But of course, as I mentioned to you before, that there are some voltage drop along the line inside your circuit that will make it a little bit lower. So from an expected value of 7.3 multiplied by 2, that is 14.6, our expected value is 14.6, right? 14.6. But only, as you will see, it will only measure 9.27. So that is our saturation voltage. Okay? So that is our saturation voltage. Because however I increase the input voltage, it will remain to that level because the voltage already saturated. It cannot go any higher from that saturation voltage. But if the voltage input can be multiplied by 2, it will. Okay, so say for example here, it's there, you see. So meaning my input voltage is less than half of that value because our gain is 2. So let us put it into a value which we can divide it easily. Okay, so let's put it into 6. Okay, let's put it into 6. That was our earlier voltage. So let's make it 4. There, almost 4, right? So our output voltage is 4. Our gain is 2. Therefore, my input voltage is 4 divided by 2, which is 2. So let's check whether our input is 2. There, exactly 2. Very nice, very good setup because the circuit is giving me the exact value which I am expecting. Okay, so this amplifier now I am going to put now into my Wheatstone bridge. Okay, so I am going to set up now the Wheatstone bridge where our experiment before. Okay, our experiment before where we studied the Wheatstone bridge as first is for determining an unknown value of resistance. Then the second one, which is converting the change in resistance into change in voltage. So I am going to connect these two now, my amplifier and my Wheatstone bridge. Okay, so I'm going to end this video now because the second setup will be with the Wheatstone bridge. Again, thank you, and you just take note of these values that I have presented to you. Include this one into your report.